In chapter 10, we're going to start taking a look at area. So we're going to do that for all the shapes that we've already done, plus a lot of different polygons that we've only ever touched on just a little bit. So the first formula that you need to know is going to be the area of a parallelogram. The area of a parallelogram is equal to its base times its height, so b times h. So looking at problem number 1a, we're asked to find what is the area of this particular parallelogram. So a lot of times what's going to happen when you see these types of problems, either in your book, maybe on the SAT, they're going to give you extraneous information or information that you don't need in order to be able to solve the problem. In this case, this 4.5 is extra information. You don't need that information for this problem. The reason why is because this 4.5, it is the base it's the base if you were to take this and then rotate it 90 degrees. In order to be able to find the area of this parallelogram with this base, you would need its associated height, which you don't have. You don't have an altitude showing you the height of the parallelogram that's associated with this base. What you do have, though, is this base 5 and its associated altitude, which then gives you the height of the parallelogram. So remember that anytime that you're working with a base, you have to have an altitude. And remember that altitudes are always going to be perpendicular to the base. So you can see here that you're going to use this line here and then this altitude here because it's perpendicular to that base. So for our area formula, A equals BH, we're going to go A equals, the base is 5, and the height is 4. So the area of this parallelogram is 20. Now, you may look at this and say that this isn't that hard. Well, it's going to get harder. In my experience, it gets harder for some students because you're going to have to be able to make these types of decisions with other problems, one that you're going to see in just a few minutes. Now, in problem number 1b, you're again given extra information. You only need 2 pieces of information. You need the base and you need the height. So take a look at you're given this side, which is one base, and then this side, which is another base. Well, which one has the associated altitude with it? We can see that this altitude is perpendicular to this base. So since these two lines are perpendicular to each other, and notice that they're not inside of the parallelogram, you actually have to draw auxiliary lines to be able to find the altitude on this. So since we know that it's going to be this base with this associated height, we're going to go 2 times 3.5, and so that tells us that our area is going to be 7 units squared. So anytime that you are working with these, remember that area is always 2-dimensional. So that means that whatever your unit is, you're always going to square that unit. Over here on problem number 2, we're asked to find the length of segment DE. So segment DE is this segment here. It's this altitude that's associated with this base. But we can't just conjure up a number. We have to figure out what exactly is that particular number. Here's what we do know. We do know this base and we do know this height. So we do know that we've got a 13 and we've got a 9. So since we know that we've got a 13 for a base and a 9 for a height, we can go ahead and we can calculate what is the area of this parallelogram. So the area of the parallelogram is going to be 13 times 9. So 13 times 9 is going to be 117. Now, in order to find this height here, what we can do is we can go back again to our parallelogram formula. We know that the area is equal to the base and the height. And so this means we've got 3 variables. We can solve if we have only one variable. So we need to see if we can fill in 2 of these variables. Well, we already know that the area is 117. So we can replace A with 117. Then we know that this base is 9.4, so we can replace the base with 9.4. So that's what we're going to do. We're going to go 117 is equal to 9.4h. Then we're going to divide out 9.4. So 117 divided by 9.4 is going to give us 12.446. So we'll just go with H is equal to approximately 12.4. We'll go over here, we'll fix this. That means since DE is the altitude, that means that DE is approximately 12.4 units long. And since we're only dealing with a single measurement here, we're only looking at distance, we're going to leave that as units to the first power because it's a linear measurement. Okay, our next formula that we're going to look at is the area of a triangle. And that's going to be 1/2 BH, or we can call this BH over 2. Okay, so either way that you've done it in the past, you can continue on doing that. I prefer to use 1/2 BH, so that's the one that I'm going to use here. Here's the reason why it looks so similar to the area of a parallelogram. So let's say that we have a parallelogram that has the base B and height H. You can see that we could just use B times H in order to figure out what the area is. If I draw in a diagonal though, what I've done to this parallelogram is I split it into two congruent triangles. And you would be able to know this by SSS congruency. So what I've done is, since I've split this into two congruent triangles, I've essentially split the parallelogram in half. And so each of those triangles is going to be 1/2 of the overall area of the rectangle. So using that information, we're going to go over here, and we're given in problem number 3, we're given a problem with a sailboat. And what we want to do is we want to find out what is the area of the sail. And so we've got 12 feet 2 inches and 13 feet 4 inches. And it wants to know how many square feet of material are we going to need in order to be able to make that sail. Here's the issue though. We're given the units, it's essentially in feet and inches. So what we've got to do is at some point we've got to convert over to strictly feet in order to be able to figure out what we have here. So what I'm going to do is I'm going to take this 12 feet 2 inches and I'm going to go ahead and convert that. 12 feet 2 inches, remember that there are 12 inches in a foot. So this is equal to 12 and 2 over 12, or 12 and 1/6. And so 12 and 1/6 is 73 over 6. Then 13 feet 4 inches is equal to 13 and 4/12, or 13 and 1/3, or instead of using a mixed number, we can convert this over to an improper fraction. This is going to be 40 over 3. Okay, so now I've got the information I need in order to be able to solve this. So what we're going to use is our area of a triangle is equal to 1/2 times the base, and the base is 40 over 3, times the height, and the height is 73 over 6. So now I'm going to go ahead and do some cross-reducing. So the 2 and the 40 will cross-reduce, and 3 will not go into 73, but we will get 2 into 6 3 times, and we'll get 2 into 20 10 times. So now what I've done is I've made this a little bit easier to solve. So I've got 1 times 10 times 73, so 1 times 10 is 10, times 73 is 730, over, this became a 1, so 1 times 3 is 3, times 3 is 9. So now I've got 730 divided by 9. 9 goes into 73 8 times with 1 left over. So then 9 goes into 10 1 time with 1 left over. So 81 and 1/9, or approximately 81 feet. But I need to know how much material am I going to need to make this. So anything over 81 is going to mean that I need to have an extra foot. So I'm going to make this approximately 82 square feet. So I'm going to get rid of that tick mark and instead go to feet squared. So 82 square feet of material. For problem number 4, we're going to need a new formula, and that is going to be the area of a square, which is going to be s squared. Hopefully you should know all this. You should know this already. You could also use A equals BH, because remember that squares are parallelograms. which means that you could use that formula for parallelograms, rectangles, rhombuses, or squares. So I'm going to use the simpler formula, which is S squared. In problem number 4, we're given what is called a composite figure. That means that we're given two figures that are either stacked or joined in some way. And what we can do is find the areas of each figure to find the area of the entire figure. So if we're looking at problem number 4, you can see that we've got a triangle on top and we've got a square on the bottom. So if we want to find the area of the composite figure, I'm going to call that A sub CF equals the area of the triangle plus the area of the square. And so all that means is I'm going to replace these symbols with the actual area formulas. So A sub CF is going to be 1/2 BH plus S squared. Now all I've got to do is just plug and play. So 1/2 of the base of the triangle, and since this is a square and the side of this square is 6, that means the side here is also 6. So 1/2 of 6 times the height, which is 8, plus the side, and squared. 1/2 of 6 is 3, times 8 is 24, plus 6 squared is 36, and so we get that the area of the composite figure is 60 units squared.